Hello everybody and welcome. This video is for the Virtual Retro Computing Fair 2020 and well, my name is Dirk Herrendoerfer. I am from the southern part of Germany, the place where Ritter Sportschokolade, cuckoo watches and very expensive cars are from. And I wanted to give a short update about the status of the Teensy port of the Altair8800 project from David Hansel. And yeah, let's start out with the beginning. So I started out on this about in November, late November 2019. Basically I did it because I was really bored. I was pretty burned out from work and I had a whole lot of years vacation left and I thought I needed something to do. So I always wanted to have an Altair and well, the only way to get one is to spend a lot of money and hope for one to appear, or to get a clone. And well, being in Germany, I thought, nah, I'm not gonna order one. I'll just try to do it myself. And yeah, had I known what transpired of this, I might not have done it. But let's continue. Up to the point, the Altair8800 emulator was only available on the Arduino Duo platform or the Arduino Mega or the PC for that part, and it meant doing a lot of wiring and it was really complex. Now the Arduino Duo is basically on its way out. As far as I know, they're no longer being produced, and the Arduino Mega just seemed a little bit, well, let's say underpowered. So I thought, okay, I could just port it to another platform and it wouldn't be so hard to do. So candidates for that were actually the STM32 line of microcontrollers, like this one here. But this one is, first of all, very small and it doesn't have sufficient memory. I then considered using the Teensy platform, and the Teensy platform has the Teensy 3.2, which I found out would also not have enough memory. Then the Teensy 3.5, which had enough memory, but the Teensy 3.6 with the added power, it has a lot more megahertz and it has a lot more memory bandwidth, seemed a lot better for this project, so I thought. And in the end, I chose the Teensy platform and I started doing a lot of hand wiring and trying to get stuff to run it all, and it pretty quickly transpired that it would be possible to run this, but it was complicated. My first shot was to just take the code that would be running on an Arduino Mega and try to port this to a Teensy and just have the Teensy work as the Mega would. But that didn't really work out, and yeah, I basically ended up scrapping that code. Then I did the other thing. I basically used the Duo branch and I stripped it down to the point where I just had serial I/O running, and that was the start of everything. As I had a serial message coming from the Duo that would indicate that code was executing on the Teensy as it was on the Duo, I was pretty confident that I could get the rest working. And so I built my first prototype board, and with the help from some friends over at JLC PCB, who I've been working with for quite a long time now, I made the board. I had this board like within 2 weeks, and it featured the Teensy, it featured a VGA output, and it featured a keyboard. Because the Teensy has so much power, I basically wanted it to do the terminal too. It would be a very simple terminal with like, I don't know, 45 by 40 resolution in 8-bit color, and in the end this worked. But this start out board needed a lot of reworks. I forgot some resistors, the wiring was wrong. I ended up cutting a lot of traces on here. But I got to the point where I actually had a running system, and where I actually could get some output from the Teensy, and I was pretty happy with that at that point. That was when things got more complicated, because I really needed to get a front panel that I could use with this. I had used switches before that, so I started out making some simple props with wood, which led to this little contraption here. This here is basically a wood version of the Altair 8800, and it had all the switches. It basically had dummy LEDs, and the LEDs were controlled through addressable LED strips, because like many other controllers, the Teensy does not have enough I/O pins to have every switch get connected to an I/O pin, and for every LED to get another I/O pin. So I basically had to make do with what I had, which meant that I would be using 1 pin for all the LEDs, and I would be using 12 pins for all of the switches, which was good enough at the time. And it works out really well. It really does. So these are basically segmented into 4 segments of 8 switches, with a scan line running over them with a timer, and that works pretty good. And in the end, I ended up going for a slightly more complicated board, and that was this one here. Nope, not this one, and not that one. This one. This board now featured a lot more hardware. It still had the Teensy 3.6, and in the meantime I had gotten the SD card working, so I wouldn't need an external SD card. The SD card is always on the Teensy. I added a serial input-output for terminals. I still had VGA and keyboard, and this is a PS2 keyboard, of course, which, because the Teensy 3.6 is 3.3 volt, these need level shifting, so that's what one of the ICs is there for. And the second IC is for the RS-232 for the terminal connection. There are several posts over here which host the LED strip and the connection to the switches and the power switch. And right at the end I also added an audio jack for audio in and audio out, which can be used with tape I/O. And tape I/O was probably the thing that took the longest to get to work. It's still a bit flaky, but I have been able to load 8K basic several times now, which is, I suppose, good enough. And the original tape was really unreliable too, so it's a pretty good reproduction of the original state. And it's a funny thing, the audio is actually completely analyzed by the Teensy. It's not interrupt driven, it is actually reading the audio in at 20 kilosamples, and it's making sense of all the data that is coming in that way, and it actually emulates a serial port going to the Teensy, just the way the real hardware would be doing it. And yeah, I'm really proud of getting that to run. So this is what I did before things really started taking off. Now, when I was done with the base design of the case and with the first set of hardware, which still looks a little bit sketchy here, but it is basically a testing and design board, and it does a very good job at that. And when I was done getting all of this to work, I was already really happy when I could do really simple things like start software, get easy things to run, and just get to the point where I could get some feedback through serial. And no matter how sketchy it was, I was very happy that the whole thing would talk to me, and that the serial was working, that the LEDs were working fine, and it actually looks pretty good. It's not as smooth and as well emulated as having an I/O pin for every LED, but that just would have made it impossible to use a Teensy, or it would have to be really complicated for the multiplexing part. And the use of addressable LEDs just seemed to be the easiest way to go for me. And personally, I'm really happy with the way this works out. And most of the things really do work pretty well. And you can actually set the behavior of the LEDs, if they're supposed to be really blinky, or if they're supposed to be not as nervous and have two different illumination levels. So you can really set a lot of stuff just to make it more pleasing to the eye. And also that did take quite some time to develop. And yeah, let's just put this to the side for now. And the software actually works really well. So using BASIC is pretty much super easy. The speed is absolutely original. You can have a 2 megahertz 8080, or you can have up to a 4 megahertz Z80, and it's the controller just simply does it. It doesn't really care about anything. All the functions that were previously around still work, so we can have a lot of the functions that we had before. We have a pretty well running BASIC. We got what? Well, maybe we don't. Oh, where did I get to now? Oh, so not everything works yet. So there's still some work to be done. But the basic things work. CPM works, tape loading works, the basic works. Most of the demos that are installed work. I even had some kids play Zork for 2.5 hours before I had to pry them away. So it is a really nice platform to work with right now. So once this was working, I set out to do some of the more complex stuff and get that to run. So let's try to get a monitor set up. So if I bring in a VGA monitor now, we can actually see that the monitor is showing all the states from the LEDs on the front panel, as well as all of the states from the switches. And this is just as long as the monitor is not used for anything else, like a terminal or for displaying stuff, this will just have the status monitor on it all the time. And it's actually pretty handy just to have it around. It doesn't need to be connected, and if you don't need it, just leave it off. You can even disable all of the code, which will make way for some more processing power on the emulator itself. But the Teensy is so powerful that it is actually working pretty well. And if I stop the code on the Teensy now, you can actually see that all the status here also stops. And if we continue, then it's going to continue on here. And we can stop it and just flip up some switches, and it's going to register on here. What I've not been able to do, or I haven't had time, was to implement a monitor for the Altair, so you could just control the whole Altair without all the switches, just through the keyboard. But I may still do that, or maybe somebody else will. And yeah, it's a lot of fun to work with this. So this is basically the most simple setup. Just hook up a VGA monitor to the emulation, and you're going to get status messages. Really interesting. Once you start doing a lot on the Teensy, the monitor display is going to start flickering, which kind of reminds me of the time with the old ZX80s that would actually blank or have some really weird interference when running CPU intensive stuff on the screen. So it's a nice touch to it. So this here is the same thing with the VGA terminal running with a basic as a terminal, and not just as the monitor. The monitor quits as soon as you switch over to using this as a terminal, and I can just use it the way you would usually use it. And I can actually see if I can get something inserted into here as a program, and it works just as the normal emulator would work. And I can use it to just enter text and everything, just as I would use a standard serial terminal or a line terminal, or a I don't know, typewriter punch type of input. And the basic behind this is the terminal code is just as simple as it can be, and it will probably change in the future, because this should be moved into the graphics library. Right now it's external, and a lot of stuff should be changed in there, but this is not my code, and it's going to take a long time for me to learn how to do this effectively. And yeah, but apart from that, I'm gonna lose now. Wait, yeah, I won. So basically this is what I've been doing to get all of this working. And when I was done with making all of these things, I got a little bit inventive, and I started making more complex boards like this one, which basically turns the Altair into a single board computer. All the mounts for the switches are on here, all the components for level shifting, serial I/O, and the addressable LEDs are all already on here. And yeah, I've been working with this for quite a lot of time now. I used my 3D printer to make fake LEDs that I already had in the wooden thing. And yeah, it's been a really long way to go with this, and I think there's still a lot of way to go. And yeah, basically that's the status of this now. And I'm currently working on the next stage for that, but this is still very, very early in its development, and there are not many of these that work. Whoops, I'm gonna break it now. No, I won't. Jeez, let go, please. There we go. And basically this is one of the prototypes of the single board computers with a front panel. This doesn't have any LED, any fake LEDs in it yet. But it does have a 3D printed bracket, and all the switches are mounted, and this is one of my development and testing boards now. And yeah, for this video, this is it. This is the status of the Teensy port for the Altair8800 Arduino project. Right now I still have all the code in my own GitHub. There are a few issues that need to be addressed before the code can be merged back to David's repo, but I suppose I'm going to start working on these soon. I've done a lot of work to make things better, but right now this code is pretty much usable, and it can be pulled from my GitHub repo, so it's available. Link will be in the description of the video. Also the link to the Altair8800 project, where most of the documentation for making the wooden box and all of the other stuff is already in there, or will be coming in the near future. And yeah, for everybody, have a good time. Right now, right at this time, stay healthy, stay safe, stay home, and have a good time. Thanks for watching, and bye-bye.